Hi everyone, today we want to talk about the introduction of applied anatomy. But before that, please allow me to make a small introduction. My name is Johnny Lim. Then I am a student studying for a diploma in physiotherapy. For this channel, I share my knowledge regarding physio. So without waiting so long, let's start our explanation. Then all the viewers who are studying the same program as me, can you write down the word same, or you may share your opinion that what I to improve in the command section? Without waiting so long, let's start our today topic. What is the meaning of applied anatomy? The applied anatomy is study the structure of the human body. Then as a physiotherapy, we must master in this course, because you will use this knowledge at your future job or clinical posting. Now I will share the method for studying applied anatomy. As you see, we got the aspect that we need to study. First is osteology, which is the study of the type and shape of the name in our body. You need to remember all the structures of the bones and their name. In our body, we have 206 bones. Then can be classified into 5 types of bone, which is a long bone, short bone, flat bone, sesamoid bone, and irregular bone. The long bones are tubular bones exp, the humerus in the arm and phalanges in the fingers. Next, short bones are cuboidal and are found only in the ankle, tarsus, and wrist, carpus. Flat bones serve a protection function. Exp equals cranium protects the brain. Last we have an irregular bones, such as those in the face, have various shapes. Sesamoid bones develop in certain tendons, muscle to bone, exp equals patella or kneecap. Let's see the structure of the bone. At the long bone, both ends of longer bone is epiphysis. Then the center portion of the long bone, we call it diaphysis. The expanded section in between diaphysis and epiphysis is metaphysis. In young children, between the epiphysis and metaphysis is epiphyseal plate. The main function of the epiphyseal plate is a bone grow in length. Next, let's see the internal microstructure of a long bone. The epiphysis is a cancellous bone. Cancellous bone, also known as spongy bone or trabecular bone, is a type of bone tissue that has a spongy, porous, honeycomb-like structure. The diaphysis is a compact bone. What is compact bone? Compact bone, also known as cortical bone, forms the hard, dense outer layer of bones throughout the human body. Compact bone functions primarily to provide strength and protection to bones, and it is one of 2 types of bone tissue. The medullary cavity is a bone marrow for formation of red blood cell. Then you can see that the blood vessels is surround on the long bone. The function of the bone is provide a framework for the human body. And it also provide the protection of our organ. Anatomical position, or standard anatomical position, refers to the positioning of the body when it is standing upright and facing forward with each arm hanging on either side of the body, and the palms facing forward. The legs are parallel, with feet flat on the floor and facing forward. Next we will talk about the myology. The myology is study about the muscle contraction and the type of the muscle in our body. The type of the muscle actually in our body, we totally have 3 type of muscle, which is smooth muscle, cardiac muscle, and skeletal muscle. Smooth muscle is found in the walls of hollow organs, including the stomach, intestines, bladder, and uterus. The cardiac muscle, also known as myocardium, is the thick middle layer of the heart. Next, the skeletal muscles are muscles that attach to bones and make up 30 to 40% of the body's mass. Muscle contractions can be classified into 2 main types: isotonic and isometric. Each type involves different mechanisms and results in distinct movements or actions. In isotonic contractions, the muscle changes length, resulting in movement of a joint. There are 2 subtypes of isotonic contractions. Concentric contraction, this occurs when the muscle shortens while generating force against resistance, leading to movement. For example, during a bicep curl, the bicep muscle shortens as it lifts the weight. Eccentric contraction, this occurs when the muscle lengthens while under tension from an opposing force, still resulting in movement. For example, during a bicep curl, the bicep muscle lengthens as it lowers the weight back down. In isometric contractions, the muscle generates force without changing length, leading to no visible movement of the joint. These contractions are essential for maintaining posture and stabilizing joints. For example, when you hold a weight in a fixed position without moving it, the muscles involved are undergoing isometric contractions. Then it is the function of the muscle. Next, let's talk about arthrology. The arthrology is study of the type and function of the joint. Since in our body, we have a lot of bones, then the bones will form junctions, or joints, to attach. For example, the shoulder joint the scapula, and the thoracic cage attach to form a scapulothoracic joint. In our body, we totally have three types of the joint: the synovial joint, fibrous joint and the cartilaginous joint. The synovial joint can be differentiated into 6 types of branches. First is the plane joint. The movement of the plane joint is gliding. The example of the plane joint in our body is the intercarpal joints are the only plane joints in the hand. The saddle joint, the shape of this joint is a reciprocal concave convex surface. The saddle joint have a 2 degree of movement. The example of the saddle joint in our body is the carpometacarpal joint of the thumb. The hinge joint, the shape of the hinge joint, can be concave and convex, but not close fit, then the hinge have 1 degree of movement. Example of the hinge joint in our body is the knee joint. The pivot joint, the shape of the pivot joint is the one bone rotate within and fibroosseous ring. The example of the pivot joint in our body, the cervical bone, the joint between the C1 and C2. The ball and socket joint, the shape of the surface is have a convex concave surface. The ball and socket joint have 3 degree of movement. The example of the ball and socket joint in our body is the glenohumeral joint. The condyloid joint, the modified of the ball and socket joint. Then the condyloid joint have a 3 degree of movement. The example of the condyloid joint in our body is the wrist joint. Next is the common problems in our joint. For this one you are no need to remember it, because you will learn it on the musculoskeletal course. Sutures are found only in the skull. They are thin fibrous bands of connective tissue that unite adjacent skull bones. In adults, sutures are ossified, meaning they become more rigid and fuse together, forming a nearly immovable joint. While sutures provide structural integrity to the skull, they also allow for some flexibility during childbirth and skull growth in infants. Syndesmoses are joints where bones are connected by a ligament or a fibrous membrane. Unlike sutures, which are very short fibrous connections, syndesmoses allow for more movement. However, the movement is still limited compared to synovial joints. An example of a syndesmosis is the distal tibiofibular joint, where the tibia and fibula bones of the lower leg are connected by the interosseous membrane. Gomphoses are specialized fibrous joints that anchor the teeth firmly into their sockets in the maxilla, upper jaw, and mandible, lower jaw. The fibrous connection between each tooth and its socket is called the periodontal ligament, which provides support and shock absorption during chewing and other oral activities. Gomphoses are highly specialized and provide a stable yet slightly flexible attachment for the teeth. Primary cartilaginous joints, also known as synchondroses, are joints where the connecting material between bones is hyaline cartilage. These joints are typically temporary and are found in areas where bones are still growing or developing, such as the growth plates, epiphyseal plates, of long bones in children. Synchondroses allow for linear growth of the bones while maintaining stability during development. An example of a primary cartilaginous joint is the epiphyseal plate located at the ends of long bones, where hyaline cartilage separates the epiphysis from the diaphysis. Over time, as bone growth ceases, synchondroses typically ossify and are replaced by bone tissue, leading to the closure of the growth plate. Secondary cartilaginous joints, also known as symphyses, are joints where the bones are connected by fibrocartilage. Unlike primary cartilaginous joints, symphyses are permanent and provide stability and strength to areas of the skeleton that are subject to mechanical stress. Symphyses allow for limited movement and serve to distribute forces evenly across the joint. Examples of secondary cartilaginous joints include the intervertebral discs between adjacent vertebrae in the spine and the pubic symphysis in the pelvis. Fibrocartilage in symphyses provides shock absorption and flexibility, allowing for slight movement while maintaining structural integrity. And you can see that this is the mind map summary of the joint that you had learned just now. But do you have in question how many movement that we have in our body? First you need know about the basic knowledge of the kinematic. As the mind map that you see, the kinematic can be explained in two aspects, which is the arthrokinematic and the osteokinematic. The arthrokinematic explain the movement at the joint surface. Then the osteokinematic is the movement of bone about a joint on the plane and axis. Here you see the analyzing of the movement and plane. But take note, usually the movement plane and axis will be perpendicular. So next time, if during the applied anatomy MCQ question, don't make a mistake in the plane and axis of the movement, okay? It is very easy. Here you see the analyzing of the movement and plane. But take note, usually the movement plane and axis will be perpendicular. So next time, if during the applied anatomy MCQ question, don't make a mistake in the plane and axis of the movement, okay? It is very easy.